Okay, today we have easy problem. Given two arrays of numbers, these apples, and this is containers. Find the minimum number of containers that will fit inside all the apples. So the problem kind of trivial. Just put all the apples into one single number sum, and then have to spread this sum into containers. To efficiently, optimally spread, we should sort these containers, and then we have to do putting these apples one by one into each container until we don't have anything left. So it's a kind of iterative process, and the total time complexity is of sorting or sort, and space complexity is also O of sort. So now let's talk about some optimizations. For example, we know that by task description we have only the biggest number is 50. It's kind of very small. With this kind of number we can sort in O of n by counted sort. Just prepare the array from 0 to 50 or up to 51 and count each number. Like if you see, for example, 23, you look at the number with index 23 and do count plus plus. And this is how count and sort works. The solution is the same when you have sorted. Like this is a frequency array, and you have to put some index j, initial position is 50, and you have to do fj minus minus to consume the container, and you have to check that you actually have any container. So this is how it works. Let's look at the code. And my solution is I use the simplest possible way to write this code. Just use sort, use sum operation, and in a while loop I use decrease the sum by the current container, and also increase the index of the next value in the container. Now let's look at some goal-fit solutions I made after. So one solution is to make a one-liner. So as we see that the size is not very big, we can use computer power to calculate the sum every time. It's kind of very not optimal. It's n squared solution, and I would say even more, because we do it sorting every time. So it's n squared logarithm n. This kind of make it possible to just find the first number of taking this largest containers. So if you have a very small display monitor and you want to write some code, here is some example how you can do it. Now let's look at the Rust solution I made. The same idea, but I didn't use this is optimal solution, and it has the same shape of 1 up to 51, just the first number and the condition happens. And another solution is the optimal of sorting with count and sort. Just a frequency of 50 elements, then you increase the frequency counter, initialize j in the last element, and then you have to move to the first position that's available. Then you consume the j. J here is a counter volume, so it's a value of inside the C. And then you decrease the counter. So that's it. Now you can watch how I solved it in minus 33 and 23 hours, or it's like minus 1 day, 23 hours, 26 minutes, and 44 seconds.